This is just a picture out of my car window. So, in erosion, there's a number of features that make sediments move. We call these agents of erosion. And wind can be that in some areas. In this area, is mostly water moving, but also gravity. So you have a steep slope; it's more likely to erode. And then, if it gets wet, it'll often wash out, like this little hillside. So what inhibits that from washing out usually is plant cover in our area. If you remove the plant cover, then you're much more prone to erosion, the movement of sediments, which then can wash away and expose more sediments to washing away. So it can kind of become a kind of a vicious process. So you can see in the upper right there, you can see a nice topsoil there. Once you remove the topsoil and you stop plants from growing, then you can expose the subsoils below to much more weathering. Here we are down at 4 Mile Run, looking at an embankment here on the side. You can see that it goes from gravel to mud, right? And that's a change in the sediment size and what's deposited. So the larger cobbles that are mixed in there, gravel and cobbles, are deposited when the stream is moving fast in that location, and then sometimes it's moving slower. So over 50, 100 years, the river may wander back and forth across the valley, and sometimes it's going fast on that side of the river, sometimes it's going slow. You're on 4 Mile Run, here, north end of Alexandria. See a nice big stream bed, and you can see where the river is currently meandering across. On that side, it's running faster. It's actually cut through a stone embankment that people built. So there's a river behind it, and the main course of the river's got lots of cobbles. But then on the near side, where I am standing, it's sort of a slower side, and so it's deposited a lot of mud on this side, on top of old gravel. But this pattern winds back and forth, and it'll be back again this way someday, maybe 50 to 100 years from now. It'll be eroding away material on this side, so we'll end up with more and more cobbles on this side, and less of the mud deposits that we're getting on the inside of this bend.
We're here at a construction site. This is an example of where humans have to actively fight and control erosion. You can see behind me that they've stripped away all of the vegetation. Plants naturally hold soil in place with their roots. So when we take it away, we have to do our best to prevent that soil from moving ourselves. Kind of fabric that allows the water to pass through while filtering the soil. And it's to prevent the dirt from flowing into Braddock Road, which would flow downstream towards
the Potomac. So here we are down where it all ends. So when the weathering breaks down the sediments, and erosion washes it downhill, ultimately it ends up here in the Potomac. So at the mouth of the rivers that drain into the Potomac, things like 4 Mile Creek and or 4 Mile Run and Cameron Run, when they come into the Potomac here, they drop all their gravel and sand pretty quickly, but the clay stays in suspension. So you look in the water here. What's the color of that water? It is brown. I can see maybe a couple feet through the water, but then it's pretty much brown from little bits of tiny clay. That clay will be carried all the way out into the ocean, and it'll drop there. The salt helps it fall out of the seawater, and it'll drop to the seafloor and end up on the continental shelf, ultimately becoming clay beds and shale beds, and someday plate tectonics will put it back on the continent. Right. But here's the Alexandria waterfront.